Hello, so today we are going to do this problem from Leetcode called implement stack using queues. So the problem says we need to implement a last in first out stack using only 2 queues. And it should support all the functions of a normal stack, so push, top, pop, and empty. So these functions here. And some notes here, we must use standard operations of a queue, so only enqueue and dequeue. So enqueue basically pushes to the back of the queue, and then we can pick or pop from the front. That's what dequeue does, and we have size and empty operations. So these are the operations of the queue that we should use. Using a list or dequeue. So basically, I think for Python we have to use a dequeue. Python doesn't have just a queue, but it has a double-ended queue. But we should only use these operations. That's the restriction we have, is to only use the queue operations of dequeue. Or I think if you are using Java, you can also use a linked list here. Yeah, so that's pretty much it. So here we add 1 and 2 to our stack. So if we add 1 and then add 2, then top gets called, so we need to return 2. Pop gets called, so we return 2 and remove it. And then we check if it's empty. It's not, because there is still 1 here, so we return false here. So that's pretty much it. Now let's see how we can solve it. Okay, so let's see how we can solve this. So let's say we have so what we want is to implement a stack. So let's just have our stack here, but we want to implement it using 2 queues. So the one thing to note is the difference between a stack and queue is that a stack is last in, first out, right? Because if we add 1, we add 2, last added is 3. If we want to pop, we'll pop 3. And then after that we pop 2. So it's the last one added is the first one that gets out. Queue is the reverse. For queue, it's first in, first out, right? And one thing to note for a queue is that there are 2 operations. This is important to note. Is we have enqueue, which pushes into the front of the queue. Pushes to the back of the queue. And then we have dequeue, which removes from the front. So what this would mean basically is if I add 1, 2, so we push to the back. So I add 1, we push to the back here. Then we add 3. But to pop, or to dequeue, we remove from the front. So we remove this one first, 1. And then after that, 2. So you can see it's not the same order as the stack here. So we added them in the same order, but for the stack we'll get 3, 2, 1. Right here, 1, 2, 3. Okay, so you can see it's a little bit reversed there. And so that's where the idea we can have here is that, okay, when we are pushing, what we want is each time we push, we want the queue to have the same order as the stack, so that when we pop, we get the same order. How do we do that? So in this queue, what we want is we want a queue to end up with 3, 2, 1, so that we can remove 3 first, and then 2, and then 1. Okay, so how do we do that? It's actually pretty simple if we use 2 queues. So what we can do is have 2 queues. So we can have Q1 and then Q2. Okay, how would we accomplish this? So first we have 1, so we add it to our queue, right? And then we want to add 2. So what we do is we move this 1 here. We want 2 to be first, so we want 2, 1. This is the end result we want. So what we can do is move the content of Q1 first to Q2. So what we want is move this here and have Q1 be empty. And then we push the element that we want. So this is push 2. And then we push 2 here. And then we take the content of the Q2 and then move it back to here. And so now we have the order we want. Now let's see how this will look like with multiple elements. So now we have Q1 has 2 and 1. And now we want to push 3. So push 3. How do we do this? So we do the same sequence, which is move content of Q1 to Q2, and then empty Q1, and then push to Q1, and then move back content of Q2 to Q1. So basically we use Q2 just as a placeholder of the elements until we push the new element so that it's at the front, because last in first out for the stack, that's what we want, and then we add the rest of the elements back. And so now what happens for push 3, we move the content of Q1 to Q2, and so what that would mean is we move 2 and 1 here, and Q1 is empty, and then we push 3 to Q1, and then we move back the content of Q2 back to Q1, so we have 2 and 1, and this is exactly the order we have in the stack, 3, 2, 1, right? 3, 2, 1. And so when we pop from the front of the queue, or when we DQ, we'll get 3 first, DQ again we'll get 2, DQ again we'll get 1, and that's exactly the order of the stack. So just so that you can really understand and the idea is clear, let's do it more with push 4. Okay, so what we do first is we move the content of Q1 to Q2 completely. So this is Q1, this is Q2. So we move 3, 2, 1. We empty Q1, right? And then we push 4. And then we move back the content of Q2. 3, 2, 1. And this is exactly the order we'll have in the stack, which is when we add 4, it's at the top. So when we pop 4 first. Okay? So in the push operation we do this, but in pop we just DQ, and so that makes it work like a stack. So let's code this up and make sure it passes. Okay, so let's code what we just saw. So we need 2 queues. We need the first one. In Python we will use DQ, but just remember, since DQ in Python is a double-ended queue, we should not use the operations that are not available in a simple queue. So for a DQ in Python we will use only enqueue and DQ operations, and these basically are enqueue is adding from the back, this is append, and then DQ is removing from the front, so it's pop left. So we only use these 2 operations and that's what the problem statement asked us to do. Okay, so we need 2 queues first. We need our first one and then the placeholder one we use. We can name these in a nicer way. Maybe we can call, let's actually just have them Q1 and Q2 to match the explanation. Okay, so for push, what we said is that first we need to move the content of Q1 over to Q2. Okay, so what this would mean is basically just overriding, right? And then we want to empty out Q1. We want to initialize it to an empty DQ. And then what we want is, the second step is to push the element to Q1, so that would mean append X. And then we want to move back the content that we put temporarily in Q2 back to Q1, because now the element is that we want to push is in front, last in, first out. The last in we put it in the front so that it becomes the first out. And so we need to put the rest of the content. So that would mean we would move the content of Q2 over to Q1. So we append the element that we pop from the placeholder Q. So Q2 is our placeholder. And this basically will move content of Q2 to Q1, okay? After X, of course, right? And that's pretty much it for this one. Now for pop, we made this in a way where Q1 always has, our invariant that we respected is Q1 always has last in element in the front of the queue. So that means to get, since this is a stack, we want last in element. We can just return pop from the front of the queue, and so to do that we just use pop left. So we use our Q1 and we pop left and we return that. And then to get the top element, we said that the top of the stack is the last in element, and we maintain that that element is in the front of the queue, so it's in the first position. That means we can just return it by returning the first element in Q1, which is 0, at position 0. Now to check in empty, that's simple. We just check the length of our queue that contains the element. We check that it's equal to 0. And that's pretty much it. So if we run this, it should pass. And it does pass test cases. Now in terms of time complexity here, what we have, our pop operation is, since we do pop left from a queue, it's constant time, or 1. And then for push, we traverse Q2 that can be at most an element, n being the number of calls to push, or the number of elements in the queue, and so it's open time. In terms of space, we are using open as well for the 2 queues. Yeah, so that's pretty much it for the solution. The other one thing we can do actually is we don't need 2 queues. We can simplify this and use just 1 queue. So let's see how we can do that. Okay, so the main idea to think about here is we actually don't need 2 queues. So how can we do it? We can do the same thing, but instead of moving the elements to a second queue, we can just kind of reverse the order. So let me explain what I mean here. So we need the same thing here for a stack. We have these things 1, 2, 3. We want the last element to be the first out. Okay. So for our queue, 1 queue here, we add first 1, and then we want to push 2. What should happen here? So what we can do here for pushing 2, we first push 2 at the end, like this. Then the second thing we can do is, what we want is moving this here out here, okay? But this here, we can get it with just the front. It's in the front, so we can pop it. So we pop this one, and then we push it again to the end. And that we get exactly the order in the stack. Now, when we want to push 3, what we do for push 3 is we do a similar thing. So we have 1, 2, and 1 already from this operation. And so what we do here is we push the element, 3 to the end, normal queue operation, and then we keep popping for the size n-1. That's what we did here as well. And so what we mean here is we take 2, we pop it, we add it here. So this is just NQ operation, and then we take 1, and then we add here. So each time we take n-1 after we push the element, and then we move it back. And you can notice here we have the exact order for our stack. And so yeah, let's write down the exact operations we are doing here. So the operation is first push x. So for pushing x, what do we do? So NQX normally, right? Then the second operation we want to do is we repeat n-1 times. We pop the front element. So pop front, right? And then add it, and then NQ it, pretty much. NQ it, okay? And that way we will accomplish the same thing we did earlier with the 2 queues. So here, let's just take another example to make sure that this is clear. So our queue currently has 3, 2, 1, right? We want to push 4. So first we push 4, then we take n-1 elements of the queue. So n is the size of the queue after appending the element, and we keep popping and adding to the back. So and queuing. So 3, we pop 2, and then we pop 1 until we do that n-1 times. And you can see here this is exactly the format of the stack where we have 1, 2, 3, 4. Now what happens if we pop 4 here? Our queue will have 3, 2, 1, 3, 2, 1 in the same order as the stack. So this works pretty much correctly. Yeah, so the operations are just nqx, and then do it n-1, we pop from the front, add to the back, that way we get the stack order. Yeah, so let's code this up. Okay, so let's adapt our solution here to match just using one queue. So we remove this q2, and we don't need to do this. We just append first our queue, and then we want to move n-1 times. So n is the length of the queue. And then we want to repeat n-1 times, so we can do that in the range of n. And what we want is to pop from the front and then enqueue from the end of the queue. So that would mean we take the queue, and this element is what we want to push. So we push it here with append. So we pop from the front and then add it in the back of the queue. And then for pop, we maintain that Q1 always has the last element in the front of the queue, so this is still, we are still doing this with this. And same thing with top, and same thing with empty. Yeah, so pretty much that. Let's run it. This is just, we just need to update the name here, Q instead of Q1. Here, sorry, it should be n-1, right? Because that way we want to move only the elements before the one that we just added. Okay, looks like there is a, so here we append, and that works. Let's submit. And that passes test cases as well. Yeah, in terms of time complexity, this is the same as the previous solution. Push is of 1 because we do this loop, and then other operations are of 1, and then our space complexity is also just 1 queue, so of n. Yeah, so that's pretty much it for this problem. Thanks for watching, and see you on the next one. Bye.